The goal for Unit 7, opener number 5, is to construct a segment that is the same length as the original segment shown here, and that intersects the original segment at the midpoint, and is perpendicular to the original segment. In order to do this, we're going to have to use a few different formulas. For each example, I'll show you the formula that you can use, but I'll also show you a different way that you could approach the problem without using a formula. For number 1, we need to find the distance from one point to the other point. One way to do this is to use the distance formula. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. I'll use the point 2, negative 3 as my point 2, and negative 10, negative 12 as my point 1. But it doesn't really matter which point I use as point 2 and which point I use as point 1. And even when you're using the distance formula, the order doesn't really matter. Other formulas like slope are a lot more sensitive. In this formula, it doesn't really matter which one you start with. We don't have to be all that picky. Distance equals the square root of x2 is 2 minus x1 is negative 10 squared plus y2 is negative 3 minus y1 is negative 12 squared. 2 minus negative 10 is 12 squared plus negative 3 minus negative 12 is 9 squared. 12 squared plus 9 squared is 225, and the square root of 225 is 15. So the distance between my 2 points is 15 units. If I don't want to use the distance formula, perhaps an easier way to approach this problem to find the distance between 2 points is just by using the Pythagorean theorem. So what I'm going to do is I'm going to take the two endpoints of the segment that's shown here, and I'm going to draw a horizontal line segment and a vertical line segment, and I'm going to make a right triangle. To find the length of the base of the right triangle, I'm going to do 2 minus negative 10, which is 12 units. This looks a lot like the first half of our distance formula. To find the height of my right triangle, I'm going to do negative 3 minus negative 12, which is 9 units. That looks a lot like the second half of my distance formula. Then I'm just going to do the Pythagorean theorem, which is leg squared plus leg squared equals hypotenuse squared. 12 squared plus 9 squared is 225, and the square root of 225 is 15 units. So you see that we get the same answer for the length of this line segment, whether we use the Pythagorean theorem or whether we use the distance formula. The second piece of this problem asks us to find the midpoint of our 2 points. There's a midpoint formula, which I will show you. Midpoint is x1 plus x2 all over 2, comma, y1 plus y2 all over 2. Midpoint formula is another example of a formula that I choose not to memorize. What we're really doing is we're just finding the average of the x-coordinates and the average of the y-coordinates. I prefer to think about it that way so that I don't have to memorize another formula. When I substitute in my points, I get x1, negative 10, plus x2, which is 2, all over 2, comma, y1, which is negative 12, plus y2, which is negative 3, all over 2. Negative 10 plus 2 is negative 8, divided by 2 is negative 4. Negative 12 plus negative 3 is negative 15, divided by 2 is negative 7.5. So the midpoint of my 2 points is negative 4, negative 7.5. I never feel completely comfortable with my answer until I go back to the graph and try to plot that point and make sure that it does in fact look like the midpoint of my segment. So I'm going to go over to negative 4, negative 7.5, And I see that not only is it on my original line segment, but it does in fact look like the midpoint of that segment. So now I feel pretty good about that. For part 3, it's asking me to find the slope of a line perpendicular to my original line segment. If I look at the graph that I've already made, I see that I actually already have a slope triangle drawn. I used it when I was trying to do the Pythagorean theorem to find the length of the hypotenuse, but I can also use that same slope triangle to find the slope of my original line segment. It is 9/12. It's not the most important detail in the problem, but I'm going to choose to simplify that fraction by dividing the numerator and the denominator by 3. So 9 divided by 3 is 3, and 12 divided by 3 is 4. So the simplified slope of our original line segment is 3/4. What that means is that the slope of the perpendicular line segment is going to be the opposite reciprocal of my original slope. By opposite, I mean the opposite sign. So if you look at my original slope, I got positive 3/4. So I need the sign to be the opposite, or negative. And then I also need the slope to be the reciprocal of my original slope. If my original slope is 3/4, then the slope of my perpendicular line must be negative 4/3. So now I'm ready to draw my line segment. I'm going to erase what I have here, but I'm going to keep my midpoint where it is because I'm going to need to use that midpoint to draw my line segment. So I need a slope of negative 4/3. And I know that I need the length of my line to be 15 units, but I think that I can eyeball it and figure out what that is without having to do any sort of distance formula. So I'm going to go down 4/3 one more time. And then I'm going to go up 4, left 3 twice also. And what I should have is a line segment that is perpendicular to my original line segment and the same length as my original line segment. Finally, the last thing that I'm asked to do is to write an equation of the line that passes through the perpendicular segment. I'm pretty sure that what that's actually asking me to do is just to write the equation of my perpendicular line segment. So what I can do is I can choose any point that's on the line, and I can use my slope, and I can write my equation in point-slope form. Point-slope form, just to refresh your memory, is y2 minus y1, y minus y1 equals m times x minus x1. I might as well use my midpoint and substitute that in as the point that's on my line. So I'm going to use y minus negative 7.5, but instead of writing minus and negative, it'll be neater if I write y plus 7.5 equals slope negative 4/3 parentheses x minus the x coordinate of my midpoint, which is negative 4. But instead of writing x minus negative 4, I'm going to write x plus 4. So there's the equation of the new line segment that I drew, which is perpendicular to my original line segment. In this opener, you saw a lot of different formulas. So before I go, I'm going to summarize what those formulas were for you. There was the distance formula, which was the square root of x2 minus x1 squared plus y2 minus y1 squared. But if you don't feel like using the distance formula, you can always just use the Pythagorean theorem. There was the midpoint formula, which was really just the average of the x's and the average of the y's. We didn't end up using the slope formula because there was already a slope triangle drawn. But slope is y2 minus y1, the change in the y values, over x2 minus x1, the change in the x values. And finally, the last one that we used was the equation of a line in point-slope form, which was y minus y1 equals m times x minus x1.